So here's this topic, inferring properties of a polynomial function from its graph. I'll talk about what Alex asks you to do, but just in general, if you were given a question like this, what does this graph tell us? So let's look at that first. And looking at this polynomial function graph, we see that it opens up on both sides of the y-axis, and by that I mean it leaves through the first and second quadrants. So that tells me it's got to be an even degree, so that means the highest power has got to be a 2, a 4, a 6, an 8, or a 10. Odd degree, by the way, would be either leaving down or up, or vice versa, going up or down. Then it would be an odd power, the highest power on the variable x. So with this one, what else do we know? Well, we see it's got 1, 2, 3, 4, 5 either relative max or relative min locations, and we can see that those occur at the following x values. So if we were asked to classify the location of a relative maximum, we'd say, well, those occur at all the tops of the hills, so to speak. So it'd be at x equals -2 and at x equals +6. The relative minimums here, here, and here appear to be at -4. Where's that? +2 and +6. And what's important to point out about those relative max and relative min locations, again, these are all x values. What's important to point out about those is that's where the graph will change from being increasing to decreasing. So we'll talk more about that here in just a second. So if you look at that graph, and just focus solely on the x values, and I'll try to line these up roughly close to where it happens, at -4, then at -2, then at 2, and then at 6. And oops, I miscopied one. That would be 8 for that relative minimum right there. So there's 6 for the maximum, and I'll back up and line those up better. That would be 6, that would be 8. I'm trying to line up with, I'll show you the color, trying to line up with these locations right here. So what do we know? So it looks like to the left of -4, if I look at the graph to the left of -4, change colors again, I'll go to this blue. In this portion of the graph right here to the left of -4, I would say the function is decreasing, because as I move from left to right, it's going downhill. So there it's decreasing. And then once you go past -4 and until you get to -2, it's increasing. And now it's decreasing. Imagine yourself on a roller coaster. So now we're decreasing again. Once you get down to that low point, while you're going all the way back up to here, the function is increasing, then it's decreasing, and then from that point on it's increasing again. So if you think about these in terms of intervals, now I'm going to shift over to the Alex screen. If you think about these in terms of intervals, and I'll just pop up their explanation, that's how they get that it's decreasing over the interval -∞ to -4. I'll show these both at the same time. Oops, scoot over. There, you can fit it all. So there's how you can see it's decreasing with the interval negative infinity to negative 4. That's this first interval right here. And then it's increasing from negative 4 to 2, then decreasing, then increasing, decreasing. So to answer their question, you just have to pay attention to the fact that they just gave you some options to choose from. So you're supposed to just choose which options over which the function is decreasing over which intervals. Choose all that apply. Well, if you look at this one from 2 to 8, 2 to 8 includes a portion of the graph where the function is increasing and decreasing, so you can't choose that option. So they're just wanting to make sure that you don't just alternate back and forth, increasing, decreasing, increasing, decreasing, that you actually look at them and decide whether the function is increasing or decreasing over that interval. If it's doing both, you don't choose that option. We've already covered B. Sign of leading coefficient, didn't actually mention that, but if it's even power and opens up on both sides, so if there's your x and y axis and opens up here, then for positive or negative x values, if the function eventually becomes positive, then that leading coefficient, what we call a, we say is greater than 0. If it ended up being going down on both sides, we'd say that a was less than 0. So what they're asking for there with that leading coefficient question right here, they're just going to asking, is that positive or negative? I don't know if it'll let me answer that question now. They're just showing as an example. And then the degree, this one either could be a 6 or an 8, depending on a couple of other things. But what you know for sure, the reason it's at least a degree 6 is that there's 1, 2, 3, 4, 5, 6 x-intercepts. Could also be 8 as well. There's some information that you wouldn't necessarily know to determine that. So I think that answers everything else that they've asked. Hope that helps. Talk to you soon.